A recap of Friday's class. Okay, so one, we had, oh, you have to look over here, Naya. Okay, so we had our data and we had our pH curves, and so we had to trace and record before the sharp rise, after the sharp rise, the equivalence point, which would just be in the middle, and then half of that, and by half we mean half of whatever on the x-axis, the halfway point, we have to record our time and our pH for that. So if we look over here, I've recorded those times, okay, and those pHs, and this should match what you have on your lab sheet, okay? I've encouraged everybody to copy this down so they have one set of good data. If your lab data wasn't that great, you can use this, and if your lab data was good, then you have two sets of good data. Okay, so the very first thing that I asked students to do was to actually figure out the Ka of the vinegar, okay? And so the important thing to understand is that when pH, when you're exactly halfway, your base and your acid will be the same number. So the log of 1 is 0. So when you're exactly halfway, you guys can go out the back door if you want to, pH will equal pKa. And so, if we look at this data over here, oh, I need a pen. Okay, always what I need. Okay, you have 4.91 equals pKa, which is the negative log of Ka. So, multiply through by a negative, and then take the inverse log. So, 10 to the negative 4.91 equals Ka, which gives you a value of 1.23 times 10 to the negative 5. And if we look at other people's data, okay, they got, go in the back door, they got these data, and the truth is that the real value for vinegar is 1.8 times 10 to the negative 5. So, not bad, okay? The other thing that I asked students to do was to figure out the molarity of vinegar, okay?
Just a reminder that everyone's going to their normal this period 5. Thank you.
So, the nice thing about molarity is you don't have to worry about any pH, any Ka, any equilibrium stuff. We're back to good old-fashioned stoichiometry, because we have our balanced reaction with a single arrow. So all you have to do is use MAVA equals MBVB, knowing that if you look on your lab handout, you'll remember that we used 2 mils of acid, we used 0.1 molar NaOH in our burette, and when students looked, they used around 16 mils. We did a calculation based on 16.9. That was the average for 7th period. And when you work that out, you get a molarity of 0.845. The cool thing is the molarity of vinegar is 0.83. So again, a very low percent error. So the cool thing is use stoichiometry, because a single arrow, to find molarity, and use equilibrium and Ka in our fun formula to find Ka. And one other thing before we pause, if you look on your graph, even though you have this S curve, you find equivalence point here. So the volume is this volume right here. This right here gave us that number. And then halfway, which in this case would be 8.45, go that many mils go up and read the pH. That is the pH that we used in this calculation. Okay, pause. Good?